Yo, hello. Welcome, beautiful people. How you guys feeling today? How we all doing? Welcome to another amazing session. I'm your host, Coyote John Balogun, your data scientist slash technical mentor. And today we'll be looking at big data operations, we'll be looking at pipelines, the orchestration, how to scale them, and processing. And we'll write some code. Yes, I said it. We've started. I was thinking we'll wait till next week, but let's just play around with something this week. I know your fingers are itching, so it's something really light, nothing serious, so relax. Anyway, how you all doing? Let me know in the chat. Talk to me. Talk to me, people. How are you finding the course so far? This is a very interactive session. If I don't see any response, we'll pause the session and go and have lunch. How y'all doing? Let me know in the chat. Let me see your emojis. How you guys finding the course? All right. Awesome. Karek says, good. I love the enthusiasm. Okay. Upembe says, good too. Cool. Nice. I'm happy you guys are enjoying the course so far. And we'll be having some fun today. So, is there any area or any aspect of the course that does it give you sleepless nights, or like Carrick and Pembe say everything is smooth sailing, everything is cool? All right, I'll take it. Everything is smooth sailing and everything is cool. So moving on. Don't forget our rules of engagement. If you got any questions, put them in the Q&A section. Enjoy our chat feature liberally, but also respectfully. Listen, learn, and engage. Sometimes I feel like adding the close and hold your popcorn and your drinks and whatever snack you have and enjoy yourself. But some will say that is not that professional. But learning has to be fun. Anyway, so before we start anything, we look at orchestration first. Because remember, today we're examining data pipelines from end to end, and we'll focus on turning the pipelines into an automated data factory. We start by defining how we move data systematically. We ensure the system can handle massive growth. That is the scaling aspect, and control when this growth happens. That is orchestration. And finally, examine how data is processed at the end of the pipeline. Let me know if I am too fast. Was I too fast? Hello, Deshro. Jethro. Okay, yes, I was tongue-tied. Hello, Jethro. Good afternoon or good evening, wherever you are. So, hope I was not too fast. Are we good? Can I move on? Okay, yep, I see the emojis. Before I move on, very good. I don't know why. I don't know that it's the emojis that made me remember. Have we all installed Docker on our various devices? Very good. And we all have the IDs, our IDs of choice. And we all know what an ID, you all know what an ID is. For you to get to this point in the course, you know what an ID is. If you've done DA, you don't Python, you know what an ID is. We all have our favorite IDs. Do we or do we not? Okay, okay. Some people have multiple. All right. So no one would be lost. Hold on a minute. Oh, no one will be lost when we get to where we are going to. Wow. Okay. So, okay, VS Code. Cool. Cool. That's cool too. So, first things first, just we'll have the explanation later. But I know our fingers have been itching. I want to give something to practice with. In summary, technically, we'll be creating a DAG, but I don't want to just go into DAGs and the rest. I think I'm jumping ahead a little bit. Just to give us a taste. Let's just see, we're setting up a simple workflow in Apache Airflow that orchestrates. You understand? So we'll come here with me, we'll come here. Okay. And then let's create a new file. Can we all see my screen? Okay, I now see why at times I can't see emojis. Sorry, pardon me. Yeah, okay. I can't see my screen. Yes. So, sorry, excuse me. I'm sure we all know how we got here. This is my ID, anti-gravity. So we came to my ID after I've created a folder for Airflow and DAGs. Because that's where your Airflow will be referencing. The guide is already there on Athena. So I'm not seeing any response. I'm guessing everybody knows how I got here. It's my own ID, anti-gravity. I create a file. Let's call this file Um, hmm, what name should I give? Let's call it Lenadag or A-L-E, same lowercase. L-E dag, L-E dag dot P-Y. Okay, L-E dag dot P-Y. Let's import date time from date time, import date time. Okay, from airflow the decorators import school. Okay. Before we get here, sorry guys, excuse me. Who can tell me where that, excuse me, who can tell me with that ringtone from what anime is from? Let me know in the chat. If you can tell me, I have a special, something for you. Okay, let's see. Um, student underscore student underscore. Who can tell me where the ringtone, where that anime is from? I have a special. No, 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 no. See. Okay, let's use my name. Or Leroy Jenkins. Cool. Let's use Leroy Jenkins. How many of you know the meme, the Leroy Jenkins meme? It's cool if you don't. Um, okay. Uh, where was I? So no one knows the anime where my ringtone is from. No problemo. Let me accept and edit one or two things. No, this should be our DAG ID should be uh, uh let's call this a demo ETL, yeah, student name. Start date, manually set, it should run daily, catch up fails, attacks, yeah, live session. It should be student name. So I just copy this and yeah, student name. Uh, okay. Okay, okay. Yeah, student name. Okay. Next, let's write the pipeline function, what it does. So in summary, but remember, this is just a lightweight example. We're not really moving or doing anything with data. We are defining the stages or heavy data. We're not defining the stages. Just to give an example of fetching, processing, and the task set for the data. So we say let's function. Let's call it okay, cheese. Sorry, I'm just seeing the chat now. All right. Cheesy. Cheesy gets the joke. Cool, cool. Okay, if you want a quick recap, okay, maybe at the end, Izu, let me do this first. I thought you guys got the recording. Please let me know if you guys get the recording on the eHub. And then, okay, absolutely. Okay, so I don't understand. I hope it's not the AI app called. I don't understand, but it's cool. Maybe explain the. I don't know. Is it the sound they're talking of? Where was I? Where was I? A function. Then now task. This should be learner score. Let's call this learner pipeline. Yeah, cool. And then a task should be uh task score ID. Let's extract actually. The Bear with me, I'll use autocomplete so we can move faster. Uh, Fetch data, and this should be in lowercase. Um, let's see, fetch data, and then should be data should be our student name. Plus ID fetch data. Let's get our student name. Fetch data return. Okay, it goes Elena. Use ALX score 85. Okay. The bank ID references student name. Okay, fine. Okay. Process dictionary. Let's go. Build. Okay. Cool. Record result. Yeah. I accept. Oh, autocomplete is then or something. And then what next? What next? Oh, I think let me set the workflow dependencies. So yeah, we just set our workflow dependencies. That's the dependencies correctly. Okay. So we say first, it's our raw data, fetch data. Okay, process data, then save this data, then our pipeline. Cool, awesome. So we're done, ready to go. Simple function. Let's run it, and then we go and look at our Airflow interface to see what's up. Wow. Okay, that's a problem. Okay, somebody is saying they didn't get the recording. Let me check if Nozipo is still with us. Nozipo has gone. I'll ask Nozipo how far she's supposed to put recording on there for you guys. But before that, let's rectify this issue. Was it this was this has been Mr. Sanko. Uh, oh, sorry. Um, let me try something. Okay, yeah. So now I think we are good to go. Let me minimize this. So we jump ahead to our DAG and check it out. So let's refresh. No, that's my DAG. See, where is our DAG should be? What's the name? We saved it as. It should be demo ELT Leroy underscore Jenkins. Said ELT instead of ETL. Yep, just seen that just now. Let me run this again. Okay. Let me refresh this. Uh, supposed to be up here. Run. Active. Post. It's cool. It's cool. Um, okay. Let me check. What is the issue? It ran. I'm not seeing it. And I'm not seeing it in what you call it. Oh, hold on. I'll fix that right about now. Um, airflow not showing DAG in ATAT. Although, yeah, I fixed that. I fixed that. Yes. Okay. Yep. All right. Thank you very much. Thank you. Thank you. Thank you. Let's check it out. Should see right about now. Oh, hold on. Hold on. Oh. The beauty of live programming. Let me do something. Log out, sign in. Um, close. So I thought this was fixed. Um, check this. Thanks again. Okay, hold on. I can't even see the other one. Let me check out something. Bear with me. This has almost never happened before. Uh, okay, airflow, DAGs. Yep, it's right here. So should be running. And that dish is it's in the correct folder. Uh, it's cool. Uh, let me search. Yeah, no, mm-hmm. It's not showing here at all. On the first one. Let me restart. Um, showing. So let's just start and see. Even the ones I've done before, I don't know why, but it's cool. We're almost there. Thank you. Yeah. Hmm. True that. Let me search for um any demo here. Okay, it's actually restarting now. Thank you for pointing that out. Hold on a minute. Hmm. Let me check. Restart it. Hmm. Okay. Come on, come on, come on. Oh, interesting. Let's try it again and see. Hmm. Yeah, with me guys, we're almost there. It's just simple, nothing to just to show, look at our graph, if he succeeded, if he failed, just a single student entry name there. So yeah, um, everything was, yeah, that's one of the beauties. Don't worry, when you're doing your portfolio presentation, you understand. It was always like that. It was by default. Uh, okay, yeah, we are we're live. Yes. So can we see our Leroy Jenkins? Let me know in the chat your emojis. Can you see our tag? So switch it on. Oh, here, let me move this. What you call it again? Let me run this. So when you run, whatever will I do with these Zoom menus? You can see the different color codes for running, failed, queued, etc. So it shows all the states. Trying to Sorry, I just want to confirm. I just want to check something. Don't don't mind me. Ah, okay. Yes. So around the first time, around the second time, around the third time. Yeah, you can look at the graph view. So you can see here, we're just, okay, this one is still running. Let's look for one that ran completely. So it's a success. We fetched our data, we processed our data, here with me, we stored what was our student name again? I think it was ALX. We processed it and then we saved it under our DAG, Leroy Jenkins. Um, bear with me. Sorry, the name. I think I should just use the same learner name and the rest, but I was just amused with the suggestion, Leroy Jenkins, and yeah. So our graph view orchestration after this. So like I said, it's just light code for today. We'll go deep in other sessions. In that session, you see when you have to reroute and say, okay, if the workload is heavy, workload is light, go this way, go that way. You see if it's failed, if it succeeded. These are the number of runs here and the likes. As you go deeper, maybe you might want to look at the Gantt chart or even examine the code to find out if there are issues. Okay, what happened? The event logs, like we'll see in the future, there was a failure, how you go through things, or maybe you put sprint statements trying to debug your pipeline and the rest. So in summary, technically, on Airflow, your pipeline will look like this. Your dark file will orchestrate the happenings in your pipeline. Those root, when you're dealing with terabytes of data, it will look like this, even though we wrote just very little code to illustrate our point. So is it making sense, people? We just give a task to, fetch, process, and save data. Are we still together? Is this making sense, people? Or have we left the group chat? Okay. So first things first. Oh, Peace says no. Okay. Cheesy, I see what you're requesting for. Peace says no. Peace, can you let me know in the chat what the issue is? What part has separated us? So the code base is fine. I'll explain it here because the same thing that you see here that is on the IDE. So I'll just use the same code that I can see here where the code is. But please, can you let me know what part, where where did we leave? Where did we get separated? Is it the code base or how we got here in its entirety or what's even happening in the course? Can you kindly let me know? Oh, exactly the third option. Cool, cool. So no problem. Um, so that's fine. So for all these sessions, yeah, there are recordings. And some people are saying they've not seen the recordings on eHub. I'm going to check with Nosy and ensure that the recordings are there along with the slides. You can watch them. Um, so before we got here, in the previous sessions, we've been talking about the various concepts we need to understand so that when we are writing code, we know what we are doing. In summary, we are working with big data, building pipelines that will extract big data, transform them and load them, or process them and load them. And we can't use the tools we've been using before. This is heavy data. Those tools will not work. We have to use tools that are specifically built to handle big data. But we have to understand the various concepts. Why are we using these tools? What tool is best for what? And even the big data, when it's being extracted, when it's being ingested, it comes in different forms. Think about data that comes in batches, some that is a live stream based on what you need. So maybe you go back, you read the content, look at the slides. So today, I'm not even supposed to be doing this today. I don't let us just give to wet our beaks and we just give a very, very light example of orchestration on Airflow, because Airflow will be our tool to orchestrate. And we do that using a DAG or a DAG file. A DAG is in, as we go down, sorry, we'll talk about DAGs, we'll go in depth into DAGs. They are called directed a cyclic graphs. This is the DAG they are talking of. This is when they say this is the DAG. Yes, we wrote code to get here, but this is the DAG itself. It's a cyclic because it doesn't want you to loop forever and waste resources. So it must have a beginning and an end. So it's not cyclic. Are we still together, people? Is it making sense, please? So I'm just summarizing, I'm just giving you the rundown to this. So you and Chizi's questions kind of tie in some ways. So she says, does Airflow essentially read the code base and implement it? Yes. That's why if there's error with your code base, you will not even see the DAG appear here. There's error, even if it's a syntax error, you will not see the DAG appear here. So your code has to come correct. And like I've been hammering from the start of this session till now, your code can be correct. Your code can be correct and what you call it, and the pipeline still be a failure. Are we still together? Do we understand? All right. So your code can be correct, and the pipe. I think I didn't want to go that in depth. It's just that's why I gave a very light example. It can be correct, and the pipeline made a failure. You see where when we get there, you see where we're trying to work the pipeline for streaming images, use our own API keys, and the rest. You find out that I will just do something. So the pipeline will show everything is successful. You check the graph, everything is success. But I'll not tell you why. In fact, you guys answer, oh, this is a wonderful pipeline. But I'll now say no. This pipeline is actually a failure. If you give a client this, you'll take it to court. Why? Because it's not doing what it's supposed to do. Um, my train of thought. So yeah. Um, Yes, use the code base implement it. Then also the code base step by step. Okay. So yes, I think I'm answering. Was I answering Peace or Cheese's question now? I've forgotten, but please, I hope I answered your question. Now, to the code base step by step. Before I begin, I want to say something. As you've come this far and how things are, do not try to cram syntax. Listen and listen to me closely. Can you guys hear me? It's good to always hammer, practice your Python, practice your SQL, so that even if the code assistant you're using makes error, you see, even there are times I have to reject its suggestion or the code compiler, I have to reject and say, no, this is not what I want, so that you know what is happening. But I will be leading you astray if I don't tell you that you should not be cramming syntax. You practice. Are we still together, people? So that's why I find that from this session onwards, we'll be writing code to the very last session we have. But I will not be saying cram the syntax. I will explain what everything does, but don't cram it. You have to know what you want to do. That's why we did Explore 101, problem solving, flowcharts and pseudocode. If I want this, do this. Understanding algorithms. Are we still together? All right. So Cheesy says okay. Yes, he said is that the decorator is for. Okay. The decorator here is it just turns Python functions into managed workflow components. Like they remove the boilerplate code and they tell Airflow how to schedule, execute, and link your task behind the scenes. So it just technically tells Airflow what to do. Are we still together? Cheesy, does it make sense to you? It also helps. I don't want to go deeper because if you're setting your execution parameters, for example, we are scheduling this pipeline to run daily. It configures the global rules for that, the start dates, the tags, and the likes. It converts the functions to operators, automates. I don't, that is a whole other, but technically, that's what your decorator does. I always to get that cheesy. Uncle Cheesy. Does that at least make sense to you? So the analogy I'll use is imagine Apache Airflow. Oh dear, what's the time? Okay. Imagine Apache Airflow is the head chef in a restaurant or a kitchen. I mentioned our DAG before. This is how data engineering, because don't be using a lot of resources. I don't want to skip too far ahead to start talking, but it's fine. You'll be using a lot of resources in the production environment. And believe you me, every little thing counts. And if I forget, please remind me when we're going to the slides. I want to use an example, a personal, very personal example of how if you're not careful. Okay. So our DAG, our directed acyclic graph, is the master recipe card using the restaurant's kitchen now. It lists all the steps needed to make a meal and specifies in what order they must happen in. Now, our task, there are individual cooking steps. Step one, chop the veggie. In this case, fetch the data. Step two, um, cook the sauce. In this case, what you call it, process the data. Step three, serve the plate. In this case, save the data. So you see that you cannot cook the sauce before chopping the veggies. Orchestration. And then you see we set our scheduler to daily. Start date and time, set our scheduler to daily, catch up. No, the first means don't start going to the past. It's just today's own. And then the student name is a variable. We put Leroy Jenkins there. And then we wrote our functions. And then you see the comment below, set the workflow dependencies implicitly. First, fetch our data. Second, process. Third, save the data. So at the end, when it comes to fetching data in production environment, you would maybe have to ingest from somewhere or load a packet file or receive batch data from somewhere, maybe connect to AWS or yeah. So the only but once you know how to do it locally, you're good to go. That's it. Yeah, don't cram. You don't need to cram syntax. You know what you want to do. And they were processing when we get maybe using your PySpark, you get don't worry, as the sessions go on, the code base will get bigger and bigger and bigger and longer and longer and longer. So it's just a very light example of what we do in ETL, extract, transform, load. I hope you still remember what ETL stands for in our pipeline. So IFO scheduler, it tells, is for example, it tells the clock on the wall, okay, it tells the kitchen team, it's 5 p.m., start making dinner. And okay, I've explained what the learner variable does. So, okay, I'm not supposed to be, but let me just go a bit more in depth. You see the at DAG works with decorator. It registers the Python function as an official Airflow DAG container, where you see the at DAG. And then the catch-up fails, like I said, prevents Airflow from running backfield instances for past dates when it's turned on. The at task, the decorator helps when you're working with workflow. It converts the standard Python functions into Airflow task using our modern task flow API. XComs is a data passing, return a value from fetch data, passing it into process data or raw data, and automatically handles the sharing of data under the hood. But don't stress about that. In fact, the main thing to illustrate was this guy. So don't worry about the code base. This is what I wanted to illustrate. And just give you a run around. If it had failed, you see it in red here and the likes. So you can see the processes here, each one with their own logs telling you, okay, this is what happened, this is what happened, this is what happened. I wanted to spend at most 10 minutes on this, but it's all good. Are we still together? Can I move on? Our light function wants to take almost the entire session, but it's cool. It's cool. I hope we picked up one or two things. So if anything, I'm just giving us, it's like a tour of okay how this stuff works. We didn't use any heavy data, just lightweight functions, just a lightweight pipeline. Just show okay, yeah, I have a feel for it. Yeah. So where were we? I'm glad. Okay, I'm seeing the thumbs up. Okay, we're good to go. At least understand. Don't worry, our dog will be with us from now for till a very long, long time. So we'll be still coming back to look at our airflow and look at stuff. I'm glad all of you have installed your Docker. So, uh, yeah, I've set up our Airflow, and I wanted to give an assignment, but I changed my mind to include data validation to check, is it truly Alex? Is it a student's name that is entering there, or is it the wrong thing entering there? But our time is fast spent. But you can go ahead and modify this workflow, look at the recording, even if you want the .py file, and go ahead from there and just have fun with it. If you want to, on your own, practicalize, edit it, modify it, it is yours. Anything you want to do, I give it to you. You don't even need to credit me. Play around with the .py file. So now, what I just did is somebody also show you, we built a pipeline for a very lightweight. We just used one row of data entry for for Alex. You just put Alex and his score in the pipeline. But believe me, in the future, you might be working with things that thousands of times heavier than this. Times you have to ingest a package file that you can understand how data is so big that it has to be squeezed into a package file. Yes. I think we've talked about package files. Have I spoken about package files with you guys? Hope I'm not confusing different cohorts. Have we talked about package files before? I'm suspecting we did last session. We did. Cheesy, fine. Then we'll soon speak about it. Don't worry. Sorry. I think I have you guys mistaken for a different cohort. All right. Fine. We'll talk about them. It's just a way to compress very big data and ingest it and work with it. So it's no biggie. But I have a feeling we did it the very last session. Yes, yes. I remember. Oh, Andrews, thank you. Thank you for indicating me. I remember we spoke about it. Yes, I will go in, but we'll go in depth them later on. Yeah, so the concepts you see, we're just allowing you dip your toe before you take a deep dive. So yeah, that's how we started with the concepts. And today I just say, okay, just for example, this is like a skeleton of a pipeline. In summary, ETL defined in our Python function. Although when it comes to task, we might be using PySpark there to specify, be working with our containers. Here, I just did it without a container, without Docker. So I can give the excuse. Yeah, okay, you guys even saw what happened, how we had to debug. Discuss something similar. I practiced with it and it worked yesterday, or was it today? And right now you saw the issues I saw. I'll be saying, but it worked on my system. But with Docker, you will not have that excuse. So once it works once, it should work everywhere. No excuse of sorry, last night it worked, or it worked on my no, you don't have that kind of excuse. So yeah, we'll be doing that. So I just want us to have the image of I just have the image of our pipeline that we built in our head as we explain this, as because we'll be seeing some things. So first things first, scalability. Let's look at the principles for building scalable software and data pipelines. We noticed we cannot treat data with the tiny tools or the other tools we're using before we got here. We're dealing with big data. So here, scalability in our software or pipeline refers to an application or system's ability to continue functioning at optimal levels, regardless of the workloads. So in the future, you find out that even on Airflow, you even tell it, okay, if this heavy workload is coming in, redirect it to this particular resource to process it. If the workload is lighter, to save money, to save resources, redirect it here. You would orchestrate that with workflow. And you see, this is usually achieved by provisioning more compute resources or by scaling the application's capabilities. And when it comes to data pipelines, scalability means maintaining functionality when the volume, velocity, or variety of incoming data changes. I know I've mentioned volume, velocity, and variety in data engineering with you guys before. Do not deny. I know I have. So we find out that our data pipelines handle business critical processes. Uh, yes, the big V's. And they provide real-time insights like live traffic updates on navigation or on navigation apps, and they are automated. So it's not something, remember I said data engineering must love automation. You must respond to changes to the load without human intervention. So if you notice there, when we came to, if you look at our code here, we set our schedule. We said every day, run it once. Configurations might differ based on depending on what you're working on. So it does not need you to be there. And then when you're routing, when you're orchestrating, it does not need to say, oh, this workload is heavy. Let me know. You should be at home sleeping, and it should be going on its own automated. So fundamentally, if the time it takes to process or execute decreases, then overall throughput and by extension scalability will increase. It might not always be obvious where to make changes to reduce processing time, but certain practices will help. So listen up. These are the concepts we are talking of. So we're entering a space whereby you have to fulfill righteousness, do everything, follow best practices, so that if anything happens for good too, if people want to replicate, oh, choose your pipeline never fails. What do? You have a paper trail to follow. So the practices we'll look at to ensure that, okay, our pipelines and software are scalable. One, looking at caching. And sorry, hold on, bear with me. Okay. Yeah, we'll be looking at caching. Sorry, give me a moment. Okay, we're good to go. We'll be looking at caching. So traditionally, fetching our databases, performing calculations, and then discarding data was common before the age of data engineers. And this meant every time you had to refetch data. So in this day and age, if you're using cloud resources, some of you who use cloud code and pay subscription to some models, you understand how much you pay when you max out. So imagine you are paying for refetching and fetching. So caching is a solution that solves this by storing a local copy of frequently accessed data near the computing resource. For example, instead of repeatedly retrieving data from a database, a local copy can be stored on a virtual machine during the processing or on a local high-speed storage volume. So in summary, caching reduces the data transfer overhead, thereby decreasing the processing time and increasing throughput and pipeline scalability. So pipeline is scalable, you are saving money. It's okay. Yeah, we all should think like founders of businesses. This scalability, all these best practices, one of the bottom line is to save money. To save money, preserve revenue, so you don't destroy the startup or the company because of your data cost or your data processing cost. Are we still together? I know we're going to mention a lot of concepts, but that is the bottom. Every business owner wants to make a profit. Every job wants to see how you contribute and deliver value to the shareholders. Although it is my hope and prayer, at the end of the session now, that you guys, apart from delivering value to the shareholders, you also do something meaningful that you enjoy. But if it's not your own initiative, or more often than not, a business looking for profit, that is the bottom line. In fact, that is one of the key. I told us one of the reasons why they will even employ you as data engineer. Are we still together? Am I making sense, people? Am I too fast? Am I too slow? So, Cheesy, what do you want me to repeat in particular? Do you mean um caching? Okay, caching. I would say, let me try and summarize caching. Caching is it handles where the data is to improve data processing. Let's leave it at that. Where is the data? caching and co-location too, but caching focuses on where did you keep the data because it matters a lot. In fact, let me tell you guys a story. I think we still have some time. So I was looking into trading with Claude. I will not tell what I was trying to trade with Claude on some markets. And then when I was doing some research, I discovered that no, you see, you just why are you jumping into conclusions, Cheesy? So you could, yes, connect to an MCP and Claude helps with the trading. In fact, Claude helps to execute it. But I was like, okay, yeah, I use Starlink, but I discovered that Starlink is not fast enough. And in fact, some enterprise or some organizations or some hedge funds or some banks, their servers, they try to use servers in the same city, if possible on the same streets, for the sake of speed, because a delay of even 1 second is like years when it comes to trading. Thank you very much. You understand? So I had to say, okay, what is the next best strategy? It has to be okay. You can't do second by second, or it has to be okay. The time it has to be maybe focusing on week by week. Yes, with your internet connection, you can keep pace, you can track what is happening, but you can't say, okay, you want to compete with the big boys second by second to execute trades, or because in fact, one millisecond is a long time. So you can see where caching comes in now. So co-location is what I was trying to even, or I give the example about, but in this case of caching, you see that it might not, it's just, let's put that, it might come in any form, but you just use the phrase here, computing resources, because um, you might be, what is this word I'm looking for? It's a very simple English word, but at times in this session, I might forget simple English words. Is the word for, let's say you're creating a setup on AWS, provisioning. Thank you. Yes, I remember provisioning. You're provisioning resources. At times, on AWS, you say, do you want to use Europe 3, Europe 2, and the likes? It will make sense if you are putting your resources on different continents, your EC compute and the likes, your EC instances. So as much as possible, thank you very much. So if you notice, we don't use the word server here because we use the word computing resource because you are problem solving. Just like I said, you are not cramming syntax or Python. It might even be in the same building. And then, so that's just an example. But when it comes to resource, it could be okay. It might even be your architecture. Remember the architecture, we did a very basic architecture drawing in the very first, was it the second session? So when you're provisioning resources, you can look at that and say, okay, this this particular data, we're going to be retrieving data from it. Let us have a cached copy close to this compute resource that's going to process it in this particular architecture. Doesn't have to be based on location or in a continent or in a country or in the same city. Do you understand where I'm getting to? Are we still together? So that's why we're not keen on saying, okay, use East 1 or Europe 2. No, the computing resource. We access this frequently. Let's keep a cache copy here. Is it making sense to you, Cheesy? Or as close as possible in this architecture, close to the computing resource that's going to process this data. That's why I can see even in the diagram, we did not use based on location here, referring to caching. Let us leave the trading discourse. We're not talking about let's leave the trading discourse. And it depends on what you want to do. If you got the example I gave, it depends on what you want to do, the kind of trading you want to do, based on the time that elapses before you execute your trading. So yeah, it's just because of speed, but leave the trading discourse. Do you understand this concept of caching now? Is it clear? Can we move on? At times, it's not always a physical location. It can be even in the same computing device or computing. You have to, okay, this cache has to be close to this, to be close to what is going to process it. Should be nearby. So there's no even, not even talking about servers now. That's why you need to be not specify and say, okay, servers, this, that. I just get that as an example. Does that make sense, Cheesy? Can we move on? Okay. So, yeah, co-location. So we are talking of what you're talking of too. If you notice, I said something, I said co-location and caching, they are similar because based on where the data is. Co-location is what you've been hammering on towards the end, where you are physically placing the data close to the computing resources that will process it. I think this hammers more on the example I gave, although it has similarities with caching. In that it works is where the data is placed. So in parallel processing, this means that the correct data partition is near the computational resource performing the processing. So we stay together. It also implies that keeping data that needs to be processed are aggregated together on the same partition, processed by the same virtual machine within a cluster, just to reduce, like you said, latency. Collocation helps to decrease the processing times. Collocation, caching, deal with where the data is. Collocation, I think, yeah, you can use the example of, okay, yeah, the servers, where you're talking about the NYSC. Caching will be, I don't know if you remember when Google, I think it still does, because the way I use Google is very different from how we used to use it back in the day. You see cached web pages. I don't know if you've experienced that before. I don't know if you guys have come across cached web pages before. Say, sorry, we cannot get this is a cached web page that is lighter than the normal web page. Oh, but has anyone experienced? Let me know, has anyone experienced that kind of thing? I've seen it. This is a cached web page. You could not access the main web page. Maybe it was heavier. This is the lighter version. I see cached web page. Thank you. Thank you. Yes. Yes. So you see, even in the same computing device or in the same computing resource, thank you, in the same computing resource, you will find out that okay, this is a cache, this is cache, this data is frequently accessed. Let's cache it so that if you want to access it, it's faster. Yeah, something like that, something like that. But co-location means okay, physically, like I mentioned, gave the example of my trading. Physically, this server should be close to where we need it for the sake of speed. So both co-location and caching handle where the data is. Pooling, centralization of you want you are pulling is what pulling. You are putting together resources for more power. So instead of virtual machines allocated to specific clusters, a larger pool of idle virtual machines are made available. You pull them together, you increase the computing power, and then you hammer the big data. You do what you want to do. It helps, it provides more overall resources, reducing the time, the provisioning time, maybe time you might need to process something. Let's say instance where maybe time will cost more, but if you use less time, you save, then you just pull your resources and get it done. It help you lower your cost. So the pooling directly enhances the ability of our data pipelines to scale. So pooling and parallel, like for example, like I mentioned, caching and collocation handle where data is. Pooling and parallelization handle how how the data is going to be worked on. I hope that makes sense. Hope I'm not too fast. So from the diagram there, you can see how our parallelization works. The full data set, it is split. So this kind, pardon me. This is when you want to work with very huge, large amounts of data. And then, sorry, uh, bear with me. Okay. So this is when you want to work with large amount of data. Break it down into little bits. They work on everything. Especially when you want to perform identical transformations on different data subsets. You now switch to your parallel execution to help reduce the processing time. And there are plenty tools, but the tools we're using for this course is our PySpark. This will support our distributed computing and helps facilitate this. So when building an application, it's important to partition it into modular components to increase flexibility and scaling out. Breaks down into little so you can work on them. I think that's simple. That is something that I used to explain all this. A huge data set broken down into different data subsets. They are worked on, so it's faster, and then you get your result. So, like we like we did in our earlier examples, you can find out that okay, Cheesy asked the question before. It was like, what was the question again? I think he said something along the lines of um come remember for the question because I need to explain it. He said something that along the lines of see, he said something along the lines of the code we wrote. Oh, where was it again? Sorry, let me look for it. Chidi said, yes, Chidi was asking, um, is does Airflow essentially read the code base and then implement it? And I said something. I said, if you have error there, if you have an error in your code, the DAG won't even show. Let me minimize this. If there's an error, you won't even see the DAG here. You won't even see the code you wrote here. Are we still together? So it's very important. You will even show up as a DAG there. It's very important that apart from things like caching, co-location, parallelization, and the likes, we also write efficient code. Even though I said, yes, it's true, your code might be correct, but the pipeline be a failure, we still need these things. We still need to be able to write efficient code. Like I said, for failure righteousness, for good or for bad. For bad, to know where the issue came, and for good, so that we can replicate and others can follow suit. So these are the things. I'm sure they've been hammering them. They've been telling you since Python. And since we're using Python for this course, first things first, don't forget your PEP 8. And don't forget, like I mentioned, efficient code is crucial for scalability. This means optimizing our algorithms. You did your, I think by the guys did your big O notation and the likes. Using high performance libraries, managing our memory effectively, and doing things like removing redundant processing, removing unused variables, improving memory and storage usage, using reusable components. For example, you saw there variable student name, implementing effective error handling. Even though I didn't really do that here or doing one of our other coding sessions, we'll do that very well. You see, especially when we're working with big data, you see how we go about that. Following best practices for specific tools and languages. I mentioned that PEP 8, among other things. So your code tool must be top notch so that you don't, as they say in Nigeria, buy market. Okay, is anything sharding? Okay, sharding and parallelization are not the same thing. Sharding is more like a data strategy about partitioning data across servers, while for parallelization is more about execution. You're working on the data when you are running multiple computing tasks simultaneously. Does that make sense? Okay. What was that? Okay, I think you've talked about television code. Okay, yeah. Next. Um, thinking, should we have even done this? Should we have done the demo before or after this explanation? Okay, let me ask one question before we go. Our pipeline we built, how many times a day is it going to run based on what we saw? If anybody can remember, how many times a day is it going to run? Thank you. The answer is in the chat. So we find out we are building stuff. Although yes, there are times you have to manually trigger stuff, but especially when you're just testing the pipeline and the likes. We find out that most of us as data engineer, if you like automating stuff, like I said, you are a data engineer at heart. Our data pipelines orchestrate the ingestion, transformation, and process and writing of data. They use a lot of complex logic, output to multiple destinations, even though here we just output to one. And then they join data from different data sets. But without a signal to let them know, do this, do that, do this, these pipelines will not do anything. This is where the execution mode comes in. These are ways we can initialize and run our pipelines. On demand, you can execute a pipeline at will, or what we call manually. Let's say you're testing. So you manually you test, you run the pipeline, you see, okay, it's good to go. So that's more often than others when you use your on demand. And then scheduled, you don't want to every time be going to say, okay, if we need, if it's a heavy load, come this way. If the load is light, no, go that way. Okay, you should trigger. No, you set your schedule. And then set up your predetermined schedule for the pipeline to run. It could be every second, minute, hour, or even on specific dates. And then event based. So this your pipeline responds to an event. And in most cases, this event is when the data is available. Let's say you want particular pipeline to run after gathering data at the close of business, after gathering data every month or yearly or weekly. So, however, it can also be in response to other events like an email being sent, a triggered alert, or another pipeline run that has been completed. There are many things that can trigger this event. So when it comes to our schedule types, technically our schedule trigger, it has a start date, recurrence pattern, and an end date. And for this particular course, we'll be working with cron tabs on our cron job. Um, is our cron utility is a time-based job scheduler used in Unix systems. If I let me jump to the good part. So with your cron on your laptop, you can set it at what time, at what day. You cannot set a specific time you want the pipeline to execute. For your MCQ, okay, this is it. The first hash talks about minutes, second one hour, the third one day, month, etc. For MCQs, you be asked questions on it. So if you're finding it difficult to understand your cron tab, just click on this link, crontab.guru, and use it for MCQs. So yeah, you put in the Chrome description there and it describes. You see here, you see 5.4 starts after it runs it next on the what's this date? Sorry. At 5 at 4, sorry, at 4:05, 8 is it run it next at this year on the 8th, 8th, I think this should be month, August, and then on the 5th. Sorry, bear with me. Okay, monthly. Let me check the slide again. Let me go back. Yeah, the third one is the month. Okay. So do your MCQ, you just come here, you copy it, you paste, you fire away. So enjoy. You don't need to, like I said, you don't need to cram syntax, or there are tools that you can use. So if you're working with cron jobs, you fire away, you use your cron tab, and then you do what you want to do. So, okay, yeah. So at times you notice when we're writing code, we are setting our cron job. You see, when you're seeing this syntax 011 hash star star star, okay, you're setting the time and when we want it to run. For example, we want the pipeline to run once a day, 11 a.m. This is the example given 011 and star star star. And then the path to the data pipeline. So our events, like we said, different things can trigger the event. An event is the notification describing, a change of state in a system or data pipeline. We're leveraging these notifications to automate and execute the next applicable task. Attention, you can see the example, in presence of a file, an email, and then the AWS data pipeline or the alarm activation, and then data processing step kicks off. So here, looking at the presence of a file, your system might need a CSV file before it starts, where the pipeline can kick off and do what it's supposed to do. And more often than not, these are the formats how the trigger file is labeled like this: succeeded, or at times failed, or maybe first date time, second date time, and the likes. And most of the time it ends with .trig to signify this is a trigger file. So the trigger file kicks off, or it signals a kickoff, and then we fire away, or the pipeline fires away. It's normally created at the end of a process, maybe retrieving data from an API, etc., etc., etc. Yes. Yes. For example, once a document has an entry bucket, yes. So you might, but when you're working with trigger files, there's, like I said, best practices ends with .trig, because more often than not, you're working with others. They're not the only one there. Others will come. They have to say, okay, is it .trig file? Okay, so this was the trigger file that started this cascading sequence of events, and then let it know what succeeded. For example, can see succeeded here indicates the associated process was successful. The first day time, the very first time that this process started, the second time, or etc., and the likes. So, example, when to use events-based triggers, you don't know the exact time the data become available. So, let's say you're working on, say you're working on a pipeline, and this pipeline, we need to know when 10,000 users wish list this video game. So you have to wait till 10,000 people that love video games wish list a particular video game on Steam, and then the pipeline can kick in. It could be an ad pipeline, it could be a pipeline for discounts, etc. So you can't put a particular time. You can't say run this pipeline every day by 9 a.m. or 7 a.m. because you don't know if 11,000 people would have wish listed the game by then. And another example is when you need the latest data available to users in near real time. So you want the data in near real time. You want to find out, okay, we want to, maybe for fraud detection, immediately this person does a transaction. Oh yeah, pardon my Nigerian parlance. Quickly, you want um the event to be triggered. And then also when you have multiple data sources, you're publishing various data formats into a central data repository. A well-designed trigger system ensures that users analyzing the data ingest the correct and up-to-date versions. So, for example, you can see how our trigger file is labeled here. So you can know, okay, is this the latest version, or is it the previous version, or is this version up to date, or is there an issue? So, end state processing. We've gotten to where we need something big to handle our big data. Talking about Apache Hadoop, this is just a very light introduction. We'll go deeper into it. But like I said, we're dipping our tools before the deep dive. Hadoop is a collection of open source software designed specifically for big data processing. Has advantages like parallelization of massive data sets and using clusters, i.e., a network of connected computers to process vast amount of data. Why Hadoop? In one sentence, one of the best open source tools for handling big data. If you want to use paid tools, you all know how it's going to go about. I'm sure a lot of us, if we have options to use paid or free models of our LLMs, we use the free models. So you can see one key advantage of our Hadoop. It is fault tolerant, it is scalable, and supports our SQL task. Because I think for as long as computing exists, we'll always have to deal with data. Even though we work with structured and unstructured data in structured and unstructured format, we always have to deal with data in rows and columns in table formats. And so far till now, SQL is one of the best way, yeah, one of the best technologies to deal with data like that. So our Hadoop supports our SQL tags through Hive. So look at components of Hadoop. At the top there is a big, just a little bit of history. They're talking about how an idea published by Google in 2006. It was an idea published by Google in 2006. Even though it's not as popular now, but I think the key things that keep it is the fact that it's open source, and things like Apache Spark, which I'm going to be using later, have come up. But a lot of big data, especially new data platforms, are built on some of the components of the Hadoop system. So just look at some of the components. Don't mind the lingo, just so we just have a broad understanding. So the components are map reduce for programming the model, for processing. Our yarn, yet another resource negotiator, helps as a resource manager, and the storage model known as our HDFS, Hadoop Distributed File System. There's always support for it, and it's extensive. If working with data collection, you can use Flume, Kafka, or Scoop. When it's comes looking at Kafka, if you're processing our Spark, we'll be looking at, and then for coordination and management, other examples like HBase, Cassandra, etc. And for SQL query, like we mentioned, using our Hive. Okay, this is the part where you are allowed to drone off and just enjoy your snacks. Enjoy your snacks, but don't stress. It's just that we need to understand the basics and know what's going on. And just have an idea. So when I use these tools, you can say, of course, don't worry, I'll be repeating them. So questions, I'll tell you, remember when I mentioned, just like I did, remember when I mentioned, yeah. So our HDFS, based on the DFS distributed file system, it's in the simplest form, it's a master node called the name node, and it has worker nodes called data nodes. Our master node records our metadata and maintains data nodes. Data nodes are the workers within the cluster, connected computing resources or devices, storing the actual data, serving the read and write requests from clients, and then the client interfaces with our HDFS to retrieve and send data to the cluster, handling both data and the metadata. And then the daemons are background processes. They are not created through direct user interaction. In Hadoop, they are created at launch. So here is just an example. For example, when the file is loaded into our HDFS, it is split into blocks. The default is 128, but you can always configure it. Each block is then stored in one of the data nodes or the cluster. The name node keeps track of the metadata. It indicates where the data block is located. And the thing is, with Hadoop, you're not seeing all this. It's happening in the background. So it's also, like I said, if you notice here, it says fault tolerant. So it handles failures by replicating data block 3 times across different data nodes. Awesome fault tolerance, awesome advantage. So we're hyping up our HDFS, showing why it's important in big data processing. And we've mentioned our yarn, how it helps with scheduling various applications and managing resources. And we're seeing that it's very efficient. It can handle different workloads like batch, streaming, graph interactive. Remember, it's big data, the data comes in anyhow. And then it's also very scalable. Key thing, can start small and it's scalable. Scalable because so you don't have to provision big resources, money is going. No, can keep it small. If it's time to scale, you scale. Okay. Then we look at our yarn, the software components. It has a resource manager containing a scheduler, helps to schedule and accepts jobs. A node manager helps with monitoring and reporting for the resource manager. The applications master, this component monitors and tracks individual applications. And then our containers. The thing that removes the excuse of it works on my laptop. So they represent physical resources like our CPU memory and storage on a single node. They are launched by the CLC, which includes metadata like our environment variables, security tokens, and dependencies. And don't worry, we'll soon be configuring our containers soon and very soon. Who knows? Maybe next week. And then we talk finally the map reduce a fundamental innovation of Hadoop, designed to process large unstructured data sets using a distributed algorithm on a cluster. So it does this using four main steps: splitting, split data into fixed size splits; mapping, each split data is passed to a map function; shuffling, relevant records from the mapping phase output are consolidated, put together, reducing outputs from the shuffled phase are then aggregated. Now, before I round off, I know that's why I put this part that I contain a lot of the card jargon at the end. Don't worry, we'll still talk about them as we go on and on. A lot of sessions will focus on even some of those components by themselves. But like I said, this is a broad overview. I just did that pipeline so we can just get our big sweat. And if you want to practice with the code there. So for today's Beyond the Pipeline session, I want all of you to check out 80,000hours.org. Are we still together? We are done. So you can come back for everyone, for everyone who got bored. I hope you guys were still with me. Are you guys still with me? Are you guys still with me? Oh, I know. Once you get here, and that's why I quickly just went. The chat becomes silent. But anyway, the thing is, as we are doing, we just when it came to the HDFS and like everything was just put together there. But don't worry, we'll break it down in each subsequent webinar. We'll pick up each segment, illustrate and say, okay, this is what this does. Here we just first, we normally start with the concepts and then we fire away and then we go deeper. So yeah, we are cool. But you can always just revise, go to recording, look at it, play around with it. But like I said, I went off us visited 80,000 hours before. I'm glad Cheesy and Sama are still with me. So I want you guys to check it out. This is for our session of Beyond the Pipeline today. I mentioned something earlier. I was talking about bottom line, in almost every business. They ask you how do you bring value? And the value is how do you help with revenue? And we're talking about scalability here. We're talking about, okay, so we don't waste resources, we don't waste revenue, make sure that the company or startup does not lose. But beyond the pipeline, life is not always about money, money, revenue, revenue, revenue. It's always about impact too. What are you doing? Are you happy with what you are doing? Are you doing something good? Yes, you're bringing revenue, but how is what you're doing affecting the world, yourself, your community at large? And this is what this organization exists for. So be you a data analyst, a data scientist, data engineer, um, there are ways in which you can practice your craft and your field in an altruistic way for the benefit of mankind. That is what 80,000 hours is. So you guys check it out. I'll ask you guys next week. It's totally voluntary, but I feel it's something every data professional should be aware of. Now to the Q&A. Any questions, please? Let me go to the, okay, I'm checking the Q&A. There are no questions. Are there any questions, people? If there are no questions, I'll launch the poll. Yeah, okay, the poll is out. You guys should kindly check out the poll. Please respond. Don't forget, you're not alone. Ask questions on eHub. If you have any issues on Fresh Decks also, technical problem, I told you, you can just take a screenshot, put it on answer base, and we're there for you. Next steps, you have two MCQs due next week on Monday. Those are triggers and schedules, big data processing. Don't forget to go to the Chrome tab website for the Chrome tab questions and just fire away. So you should ace those MCQs. Remember, you are not alone in the community. Your alumni, volunteer mentors are there to support you. Post your wins, challenges, and your insights on all your platforms, LinkedIn, anywhere, just fire, because like your CV too. Um, So, Cheesy, I'm seeing your question. I want you to check it out. That's what it's all about. Check it out. Check it out. It's a gift. Check it out. Yes, I want you guys to check it out. Especially as a data professional, I want you to check it out. Yeah. So, I'll be seeing you all next week. Enjoy.
Ọ̀nà ojú wa, o ti náwó sójú. Àbálà gangan. Loud girl. I might link my team from motion. 7 a.m. in the morning, she's calling, I'm yawning. She's jarring, no stalling. I might link my team from motion. 7 a.m. in the morning, she's calling, I'm yawning. She's jarring, no stalling. I might link my team from motion. 7 a.m. in the morning, she's calling, I'm yawning. She's jarring, no stalling. I might link my team from motion. 7 a.m. in the morning, she's calling, I'm yawning. She's jarring, no stalling. Come on, baby, let's go by me. I don't do for your matter since 2 years ago. Even your mom says I've coming. I buy hands on privileges, mellow, that's nice things. Ọmọ ìyá bọ́n fìtà, bá mi bọ́mọ̀ rẹ sọ̀rọ̀, bóyá tú mi síta. People don't collect bribe for your matter. Ó ti sú mi, I don't tire for this matter, baby fella. Baby, if they make my head, they sharpen to back my fún mi lásán. Má gbé ẹ lọ sí àǹkẹ́. You make me the lost appetite. You prefer sick to ring party. You know me very well, you know say me I be your show. Then they call me come on, baby, oh yeah, come on. I like me to party, come on, baby. When you move around, if I buy move around, I'm fighting from motion. 7 a.m. in the morning, she's calling, I'm yawning. She's jarring, no stalling. I might link my team from motion. 7 a.m. in the morning, she's calling, I'm yawning. She's jarring, no stalling. I might link my team from motion. 7 a.m. in the morning, she's calling, I'm yawning. She's jarring, no stalling. I might link my team from motion. 7 a.m. in the morning, she's calling, I'm yawning. She's jarring, no stalling.
Kí ló happen now? Ọmọ pẹ́ ọ́n dẹ̀ ń pé ó dẹ̀ ń ṣe falafolo báyìí. Àsúnmọ́ bí yìí ó ń pè é. Ó dẹ̀ ń lọ kí ló fẹ́, owó ló fẹ́ ni. Èmi ò ń ṣe àwọn oní kébékébé ọmọ. Má lọ sùn lé, súnmọ́ bí báyìí.
Baby tó ń lọ yẹ ẹ̀tọ́ wa ni, ọ̀lẹ tó ń lọ yẹ ẹ̀kọ́ wa ni. I don't notice more of running. See this baby, oh, to an if you know where me come from, you know go ever use me, shako chupa. I come from Moshine City, my people, them know what I'm capable of. If everybody tell me, say I know they don't I might link my team from motion. 7 a.m. in the morning, she's calling, I'm yawning. She's jarring, no stalling. I might link my team from motion. 7 a.m. in the morning, she's calling, I'm yawning. She's jarring, no stalling. I might link my team from motion. 7 a.m. in the morning, she's calling, I'm yawning. She's jarring, no stalling. I might link my team from motion. 7 a.m. in the morning, she's calling, I'm yawning. She's jarring, no stalling.
They don't mix this.
Ọ̀nà ojú wa, o ti náwó sójú. Àbálà gangan. Loud girl. I might link my team from motion. 7 a.m. in the ọ̀nà ojú wa, o ti náwó sójú. Papala gang.
Like a ball.
Loud girl. I might link my team from motion. 7 a.m. in the morning, she's calling, I'm yawning. She's jarring, no stalling. I might link my team from motion. 7 a.m. in the morning, she's calling, I'm yawning. She's jarring, no stalling. I might link my team from motion. 7 a.m. in the morning, she's calling, I'm yawning. She's jarring, no stalling. I might link my team from motion. 7 a.m. in the morning, she's calling, I'm yawning. She's jarring, no stalling. Come on, baby, let's go by me. I don't do for your matter since 2 years ago. Even your mom says I've coming. I buy hands on privileges, mellow, that's niceness. I'm a yabon vita, but me bama resoro. For you to me sita, people don't collect bribe for your matter. But you sue me, I don't tire for this matter, baby fella. Baby, if they make my head, they shampoo to back my formula song. My boy, lost the anchor. You make me the lost appetite. You be fancy, Tory, but you know me very well. You know, say me, I be your shaman. Then they call me, come on, baby, oh yeah, come on. I like me, they pass it, come on, baby. When you move around, I'm a late night from motion. 7 a.m. in the morning, she's calling, I'm yawning. She's jarring, no stalling. I might link my team from motion. 7 a.m. in the morning, she's calling, I'm yawning. She's jarring, no stalling. I might link my team from motion. 7 a.m. in the morning, she's calling, I'm yawning. She's jarring, no stalling. I might link my team from motion. 7 a.m. in the morning, she's calling, I'm yawning. She's jarring, no stalling.
Hello, kí ló happen now? Ọmọ pẹ́ wọ́n dẹ̀ ń pé ó dẹ̀ ń ṣe falafolo báyìí. Àsúnmọ́ bí yìí ó ń pè é. Ó dẹ̀ ń lọ kí ló fẹ́, owó ló fẹ́ ni. Èmi ò ń ṣe àwọn oní kébékébé ọmọ. Má lọ sùn lé, súnmọ́ bí báyìí.
Baby, don't lie, yeah, it's funny. All I don't lie, yeah, honey. I don't notice more of running. See this baby, oh, 20. If you know where me come from, you know go ever use me, shall you go. I come from Moshine City, my people, them know what I'm capable of. If everybody tell me, say I know they love everybody moving out I might link my team from motion. 7 a.m. in the morning, she's calling, I'm yawning. She's jarring, no stalling. I might link my team from motion. 7 a.m. in the morning, she's calling, I'm yawning. She's jarring, no stalling. I might link my team from motion. 7 a.m. in the morning, she's calling, I'm yawning. She's jarring, no stalling. I might link my team from motion. 7 a.m. in the morning, she's calling, I'm yawning. She's jarring, no stalling.
They don't mix this.
Zimbabwe, Mukarama, Funga, Koledano.